This is question number 23 of Ncert. Prove that the volume of the largest cone, that means what is largest cone, volume of cone, that can be inscribed in a sphere of radius r. Radius r, it is given, hence it is constant, is 8 by 27 of the volume of the sphere. We have to prove that volume of the cone is 8 by 27 of the volume of the sphere. Hence, what is given? Radius of sphere. What we need to prove? Volume of cone is 8 by 27 of the volume of the sphere. What is maximum or largest? Volume of cone. Hence, which is largest or maximum, that will become the main function. So we know that the volume of the cone is 1 by 3 pi r square h. We need radius and height of the cone, that is inscribed in the sphere. Inscribed means a cone is being drawn inside the sphere. Now look at the figure. Let the radius of the cone be r and radius of the sphere be capital R. So OA is capital R, OC is capital R, and let OB be x, and BC becomes small r, that is radius of the cone. Now from figure we conclude that radius of the cone is BC and height is AH. AH means OA plus OB. OA is R, OB we have let it as x. BC is the radius of cone, small r. Now from in triangle BOC, r square is equal to small r square plus x square as per Pythagoras theorem. Then from here we can get the value of x. Putting the value of x, now we can see the function, volume function, is reduced in the form of capital R, small r and pi, where pi is constant, capital R is constant, and only one variable is there, that is small r. When we distribute r square with this r, we get r into r square, and when the r square get inside the square root, it becomes r to the power 4. Hence r square r to the power 4, r square into r to the power 4, that is r to the power 6. Now it is ready to be differentiated with respect to small r. From here we can conclude that r square gets differentiated to 2r. From this we will, as per the chain rule, we will differentiate it. First derivative is ready. Now next step, dv by dr is equal to 0. From here we can get the value of small r, but as it is in the form of root, we have to solve this by squaring both sides, and then we will get the value of small r in the form of capital R. Now when we differentiate again dv by dr, we will get the second order derivative, and see that it is very much complicated. It gets complicated now, as the value after putting the value of small r should be smaller than 0, as we know that we have to prove it as maximum. Hence double derivative should be negative. Moving ahead, that prove itself that it is maximum. Now we have to prove 8 by 27 of the volume of the sphere, volume of cone 1 by 3. This we have got from the last equation, that equation number 1. In equation number 1 we will put the value of small r, and from here we can conclude that the volume of small cone inscribed in the sphere is 8 by 27 of the volume of the sphere. We can consider here that we will take LCM, then r square by 9 under root will become r by 3. Again we will take LCM. From here we take out 8, 9 into 3 27, and leave 1 3, 1 4, and 4 pi r cube, because 4 3 pi r cube will become volume of the sphere. Hence we can see volume of cone is 8 by 27 of the volume of the sphere. But students, from here we have seen that the second order derivative is very complicated, which will be a tedious work to solve. Hence, we can choose another method to solve the same question, where we will take OC as X, OB as capital R, and from this we can take AC as AC in triangle AOC by Pythagoras theorem R square minus X square, and PC, that is height of the cone, OP plus OC R plus X, volume of the cone 1 by 3 AC square into AC height pi square H. AC square we have found here already, capital R square minus X square. PC also we have found here, R plus X. Then we will expand this binomial function multiplied by binomial function, and this is ready to get differentiated. This is in the form of one variable, and variable is X, as capital R is a constant. Differentiating both sides with respect to X, we will get this form. Now, as equating it to 0, we will get the critical points. This is a form of quadratic equation. This is in a form of quadratic equation with respect to R. Now we will factorize it. Minus 2rx. We can write it as minus 3rx plus rx. We will get same thing. Now from this and this we will take r as common. From this and this we will take x as common. From here we get r minus 3x, r plus x is equal to 0, r is equal to 3x, r is equal to minus x. Since r cannot be negative, we can neglect it. Hence, the value of x is r by 3. Now again we will, now again we will differentiate the first order derivative, that is dv by dx. From here we can see that r square minus 2rx minus 3x. Again we will differentiate it. 1 by 3, pi is constant, r square is constant, hence its differentiation is 0. 2rx will become 2r into 1, that is 2r. 3x square 2x, 2x into 3x, that is minus 6x. Now we can put the value of x, that is r bata 3, in the second order derivative, and we will see that it is a negative, which means that at x is equal to r by 3, volume is maximum. This is the second approach of question number 23. From this we can conclude that any question can be solved in multiple number of ways. Few will make our function easy to be differentiated, few will make our function hard to be differentiated. We have to choose the process very wisely. We have to choose the function very wisely, which will make our work easy and save our time.